All right, so I'll just pause here for a bit because I've explained a bunch of things, and I just before starting on like actually hacking on code, I would like to break for a second and ask if there are any questions. Yeah, on and receive handler is going to receive whatever the client is going to send, and there is going to be a receive handler on the client also, which is going to receive whatever the server is going to send. But this part that I was showing a while ago, this particular part is on the server side. There is a similar, yeah, yep, that is correct. Yep, absolutely. All right, so let's start with some Clojure hacking. So I have bunch of like things that are already there in the Clojure script file. These are already loaded. The functions are already loaded, right? These are just functions that I've written to kind of draw a grid, which is similar to r/place. Um, and then you have some comments. I didn't want these functions like this code to be evaluated yet. I just wanted it just so that I can have a cool demo with the REPL. I just find it very fascinating that I can use a REPL on my browser. So I always find things like this very cool where I can evaluate things and it shows up in the UI like this. Right? So you have a basic grid and I think set zoom kind of does draw grid also, so I don't have to evaluate it. And then I have few helper functions which are going to help me draw dots on it, right? So I have one that says drop grid pixel on second column, which is zero things index, and then first row, right? Then I'll have one at 0, 0. Our goal is to eventually make this collaborative, right? So your backend server is going to send and broadcast whatever everyone else is kind of clicking on and get us the latest state. Okay, so we have the base setup. Now we'll see like how we can communicate between the front end and the back end and how all of that becomes easy with Clojure. This is the part, Rasia, that you're talking about with like WebSocket handlers for ClojureScript. So I have a function called setup WebSocket, and then I'm going to create a WebSocket connection, which is pointing to that endpoint. And then here is what I have when like anything is coming from the server's point. I'm going to receive and have it here, right? So let's try this out. Before that, I can even open up the inspect and see if there are any new WebSocket connections that set up because of this. Oh, oops. I think I need to reload my page. Just give me a second. I need to figure this one out. Yeah. I have uh, deliberately not enabled autocompile, which is a default Shadow CLJS thing. But since I'm going to save files also, I don't want my REPL to go away and page to refresh. I just don't like that experience. So for this particular stream, we are closing that, but the same default for Shadow CLJ is to kind of auto compile and load. So for this, I'll have to do this manually just because I had to reload the page. And do we have a WebSocket connection? Not yet. Maybe because of that. Yeah, there you go. I think there was an error here which did not let me create a WebSocket connection because this was not defined. And we have a WebSocket connection now. We can also send things back to backend, right? And now we can switch to backend and see if it is actually receiving these things. Uh, I know there are a lot of like debugging tools in Clojure, and this is an anti-pattern, like a big no in production. But this is something that I keep doing when I want to inspect things in a REPL workflow, and I keep using this. K doesn't mean anything; it's just my name. That's why I use K star. Star implies that this is a mutating var, and you shouldn't like refer it anywhere else in production. I'm going to reevaluate this and again send something from front end and see if this value gets updated, which means this function was called from the server and we have our data. The first thing in this vector is HTTP channel. You can use this channel to send back data to front end, just like we did from front end itself, and we have our data. Okay. Uh, Now the question is, what can we do and what kind of data do we need, right? This is where defining the type of data we want and the structure of data is important. So let's define that first in the front end because that's where most of the action is anyways. Um, Let me switch back. Okay, so what we want is the WebSocket to receive bunch of data, ideally in diffs, and tell the UI that, okay, I think somebody has clicked on a pixel and you should draw this pixel, right? So it's kind of like calling this function, but we need it in data form. So one way of defining this data is saying, okay, data looks like my first position in this vector is a column, right? So let's call it as it is, then row and the color, right? But we can also send a list of data because uh, this is an optimization that we can do in future that we don't want to send data one by one. We can just send a list. But for now, we just say that, okay, this is the smallest like unit of data that we want to send from backend to front end, and this should kind of render things. Uh, I don't like this way of defining data because it kind of loses information, even though it's kind of maybe less in size. It's hard to debug, it's hard to look at and say that which is which. I will also lose track of things. So what I usually like to do is define it something like this. I'm saying column 0, row 1, and color red. Right? So we have our data. What we can say is we can expect this data here, and we want to do something with this data. I don't want to call this data now. Call it sample data. All right. We want to draw pixels. Okay. And we can destructure this guy. Wait. Let me do it here. All right. So we have a way to kind of handle incoming data from backend if it's in this structure. There is a slight problem here because we are expecting that whatever this WebSocket is sending, uh, it's in Clojure data structure, but it's going to be in a string format, right? So we need to figure out how to read this string. My favorite format to do anything related to Clojure data structure is Eden. You get that for free, so you don't need to serialize in JSON. So I'm going to expect this data to be in Eden format. CLJS has a Eden reader. Let me just look up the documentation. Or if anyone knows how to read strings from CLJS Eden wrapper, please feel free to chime in. Oh, there you go. Okay. We can test this guy out now by creating a screen. Okay. Okay, so what we did here was we have our sample data which says column 0, row 1, color red. Then we converted that into string because that's what we are going to get from backend on a WebSocket channel. Then we wanted to test our WebSocket message handler if it's doing the right thing, and it is. It's first converting the string to a Clojure data structure, then it's destructuring to column, row, and color, and then calling the right function, right? We might need more things like we're just assuming that, okay, everything that the backend is going to send is raw pixel, but for now, let's assume that and see if we can do more things from backend now. For this particular work, I'm just going to switch to backend REPL right here in this window instead of switching to backend itself. So we can see like if frontend is actually doing what it's supposed to do. If not, we'll have to fix that. So let me switch to backend code. All right. We have a reference to the channel, which is first of this. Then we are going to copy our sample data from front-end code. Right, we have sample data. We are going to convert it into string. And then we are going to send it over this channel. Okay, this worked, but we don't know if this worked here. We have our data, if you can see, coming from the backend now. as column 0, row 1. But we should change the sample data to something else just to see if it's working. Yeah, let me make it even more obvious. Yay, like we have back into front-end communication. It's working. Uh, Data serialization, deserialization was just PRSTR and Eden Reader. We have hit a milestone that back into front-end communication is happening. So we are here now, send canvas updates. All right, so what else can we do? Let's have some fun now with this nice little functionality before we actually implement more things. Uh, we can like just send random, like we have like kind of like a LCD display and we have a backend which can kind of render different things. So let's generate some more data. No, no, feel free to interrupt. Feel free to interrupt. It's completely fine. Yeah, yeah. Mhm. Yeah, yeah, yeah. Yeah, so ideally, what we are going to do is imagine this UI is like opened by hundreds of people on this Discord, right? And everyone is kind of clicking on, okay, I want to paint this red. Somebody's saying, I want to paint this part blue, and things like that. So that might create a problem because polling for that will work technically, but then between each poll, I'll have to kind of buffer that. Okay, now my last poll was like you have to manage some kind of cursor to say that I have received poll till like some timestamp and it give me every updates after that timestamp, right? So your server has to manage that state now, which in case of WebSockets, it's slightly simpler. I mean, even WebSockets, if you go like if you become really pedantic, you really need cursoring there also because if you refresh your page, you might lose updates, right? So there also we need to do that, but it's slightly less complex than what you need to do with polling. So yes, for especially use cases where you're sending a lot of updates to your UI from backend, you will deal with lot less problems with WebSocket because that's what it's built for. Yep. This is a good place for like any other questions. So we are already at a milestone. Anybody joining in late, if this doesn't make sense, feel free to jump in also. Can you folks see my cursor? Hello, hello, hey. Sure. Uh, yeah, yeah. So that is just me because I am not a front-end person. I don't know the latest frameworks to use. That's why the UI is also very basic. So it's just plain old ClojureScript and your HTML5 and browser APIs. But there is no good reason for not to use it. Yeah. I, I mean, you can like still add like React to this mix and it should work. Uh, all we are doing right now is connecting data from backend to frontend. The React. anyways doesn't solve for that. So this part you'll still have to implement in the same way that I've shown. Yeah. All right. So let's build something that we can send in like as lots of data and see how our front end reacts. So I'm going to take a range of 40 pixels that I want to send. Hmm, Let me map over it. Actually, since our grid is not that big, let's keep it to 20, column I, row I, and let's pick a few colors from a nice color palette site. I'm going to create a different place for colors. This is too white. Yeah, I always end up on this site once in a while. Does anyone remember? I think there's a Clojure core function which helps you pick up a random element from a vector. Meanwhile, I'll check, but if anyone remembers, please chime in. I end up on this cheat sheet more than I can remember. My usual mental model is kind of think about what I want to get done. In this case, I want like one single element out of a vector. So this is seek in, seek out. This is not useful. Maybe using seek, yes. Extract an item, definitely yes. Oh, there it is, random. I have really bad memory, so this is a very useful page. I always keep it open. And there you go. We have random elements. We can use this here. Uh, let's try it out. Before that, let me open up UI. Oh, there you go. And if I keep sending it again, oh, because this thing is already evaluated, it's not changing. Let's use this map as it is in the DoSeek. Yeah, we can do that also. Uh, is it like this? Oh, no, that's 20. That's right. Oh, it's a. Yeah, you have to map over anyways to create like a 20 pixels, list of 20 pixels. We are just ignoring this now, right? We're just using it as a mapper. Yeah, there you go. Creating. Yeah. Hopefully this will be like from all the members who are clicking on the pixels. So, okay. So coming back to Clojure land. Now we have to figure out a way to click on this. and this sends data back to backend, and then it broadcasts, right? Uh, what can we do now is add an event handler. I had added it in comments because I don't have a good idea of how to add event handlers in JavaScript also. So I think this is will do it. I have a click handler which is saying if I click on surface, oh, there it is, right? But this is not going to send anything to backend, right? What we want ideally is just like that's basically the concept of r/place is people are fighting for pixels, uh, and they're kind of collaborating, like collaborating and fighting at the same time. Some small communities would want to kind of create a logo of a game that they like, or create a flag, or things like that, and they'll capture a part of the canvas. And this is a very small canvas. That one is, I think, 10,000 pixels by 10,000 pixels. So we'll get there, baby steps. That will also kind of help us understand what is the memory footprint of these data structures when we look at like a massive scale. Currently, it's I think 25 by 25, so it's very tiny compared to the Reddit's canvas. So now we have to send this, and what happens is when I refresh this page, this will all go away, right? We want to persist this data, whatever we are sending here, back in backend. So first, we'll just figure out how to send this data. We have a function called handle flip canvas, right? It's kind of drawing the pixel, but at the same time, we want to like kind of also send this data back to uh, your backend. So we have to have something like send pixel. Let's define it here. And it will have XY color. We have a reference to our socket, and this is how you send stuff back to backend. This we have established. So let's try this, and as we have seen, we will need something in column X, row Y, color. Okay. All right, this is not doing what we want it to do. Maybe the click handler needs to be set again. I don't know how JavaScript handles this, that this is, I think, being passed as a value. So we need to add one more click handler. That's my guess right now. So I'm going to just evaluate it again. Yeah, there you go. So what just happened now is the first time we had defined handle canvas click, it didn't have send pixel, and the whole function got passed to this event handler, and we did not have any way to kind of change that. So we just added another click handler, which is basically first one is calling this again, and the second one is again drawing the pixel, but it doesn't matter visually. It doesn't do anything else, but we are also sending the pixel back to backend, right? So we have this WebSocket different direction of communication happening, and now we can switch to our backend code. And if I check K star, because it's kind of capturing everything, you can see this guy is stored. Okay, so we definitely need to change this implementation. So let's start writing it. And since we have a reference to K star, we can just test out the whole thing without doing anything in UI. That's the brilliance of REPL-driven development. You can test out things in isolation if you have set up things the right way. Um, We'll just do a read string here on data that will give us keys column, row, and color. And for time being, I'm just going to print them. Yeah, so we have our data destructured with the row column values. Interestingly, this value is wrong, so we need to fix it when we are sending it. So I think these values are the actual canvas pixel and not the grid pixel, which is a much bigger block of thing. So that data is not something that we were expecting. So let's go back to send pixel, and we need a way to kind of figure out how we can change this X and Y. I see. So what is happening here is it is doing the math to figure out the actual grid and X and Y. So this is a great place to write helper functions. Oh, okay, I don't need to do this. I just need to change this. So canvas. Let's test this guy out again. Top pixel. Okay, and send pixel also needs this. So what was the function? Yeah. Okay. So do we have the right pixels? We don't. Hmm. I see. We don't need this actually. Yeah. So these are the right coordinates that we want. Just like, let's click here, which is a better example. Column 1 and row 0. We are sending the right things now. Switching back to this guy, we can see it's getting printed because that's what we have done in backend. Just print whatever data is coming in and destructure it. Now, here I want like folks to discuss that, okay, there are two problems here, two things that we need to solve from this point on. That front end is sending back a pixel clicked. One is we have to persist this data somewhere, mostly in memory, because we are treating the Clojure backend runtime as database. We don't want to store it in other database. This is a constraint that we have added just to highlight Clojure's concurrency constructs and Clojure's power. The other is how do we kind of broadcast it to other WebSocket channels. I think that's something that we can take it for next session. But for now, what do we suggest that we do to store this data in a format that we can reuse? So one thing we can do is we can define a state, which is an atom, right? Uh, what will be good Clojure data structure to use with this atom? Questions for everyone on stream. Should we use a map or should we use a vector? Yeah, but that will just to help you store one pixels update, right? Uh, we want to store all the updates that we have done so far, right? So what we want is that I click here, I click here. Sorry, could you repeat that, please? The state, yeah, the state should be all the updates that are happening to the canvas, which is all the clicks, right? So that way, you can think about this like you are storing all the diffs that are happening to your database. And if you apply all the diffs, you can construct the final state, which is the latest view of this your canvas. So if you are recording all the clicks from everyone on the canvas and apply them in a chronological order, you'll you should get a canvas view which everyone saw. Yes. I'm so happy that you got that because I was kind of hiding that fact and I was hoping that somebody picks on that. Thank you. So we can like store it as a yes, yes, we will get there. So the idea is to kind of do things and see if it works. And once we hit the limits of those pattern, then we will optimize. It's kind of like taking steps deliberately slowly and not towards optimization until we need it. I mean, you're right. If we were to design a production system, we would have done that. But just for learning, uh, I would recommend that, okay, let's do the enough. Sorry. Yes, yes. Yeah, 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 yeah. Do you want me to go back to that? No, no. I have implemented that. This one? This we just implemented it here. It's just using a JavaScript send and it's referencing to a socket which we have created. So this part is as good as like JavaScript call to WebSockets saying send this string. So this would look something like in JavaScript if I had created a socket, right? Socket, new WebSocket. Right? Yeah, it's just a function call with a string, right? This is exactly that. So we are not doing anything. The special part is just we are serializing our data structure and sending it over WebSockets. Right. We could start using channels when the need arises. Uh, for now, we are not using them because we are doing everything synchronously. And doing everything synchronously is also easy to debug if something fails. Right? So we will definitely need channels once we start handling things in backend where we need to optimize a few things. So coming, yeah, this is usually a convention which is saying that this is causing a side effect, right? Uh, as opposed to a function which I've written here. There should be a function which, if I were to write a function which generates random data, right? It's not causing any side effects. So I wouldn't put bang at the end of it. Bang just implies that this is causing a side effect. So it's not a pure function. This is a closure convention that is used everywhere. This also in the library also, if you see HTTP kit, which we are using, there is convention of adding a bang. So if you see, there's a library function called send. It has a bang at the end because it's causing a side effect. It's sending something on this channel. It's causing IO. So any IO function usually has a bang in libraries or in your code base also. Exception being println. Println is also causing IO, but it doesn't have it because it's just writing. It's technically it's a IO operation, but we don't add it there. All right. Any takers for defining what we should have here and how we should change this println to update this state? Okay. Okay. Right. So basically, it will look something like this, right? And what we want is this state to be updated whenever it gets an update on the channel, right? We are already printing that update, so we already have the data in place. So all we need to do is store this data, right? Uh, uh, people who have not used atoms, you can take your shot at like writing this S expression. You can just tell me what needs to be written here so that this state starts holding all the updates that the backend server receives. Perfect. Perfect. And then just adding, yeah, we don't want data because it's in string, so we'll need pixel data. Perfect. So we'll remove the println, we don't need it anymore. We'll update this guy, and let's go back and click on a few pixels. If we clicked on 3, the state should have 3 pixels. Oh wow, it already has so many things. I see. So it is repeating my clicks a few times because I have my click handler evaluated a few times. So it's calling the same function multiple times. Let me just refresh my page, reset the state, and see it again. I'm clearing the state back to just empty, refreshing this guy. What I'm going to do now is, since we have fair amount of code written, I'm going to uncomment a few blocks and recompile my Clojure script. I don't want to do this by hand. Okay. Switching to terminal, just so you guys can see what I'm doing in Shadow CLJS. I'm going to stop the REPL. This has been shut down. I'm going to ask it to create a new build. Hopefully this should compile also. Switch to our front end again. This has not started yet. Yeah, sure. Just give me a second. I'm just debugging why this terminal is taking so much time. Okay. Okay, I'm going to show you in the REPL itself. I'm going to define a new state. Okay, just for okay, this is my atom. Right? Okay, so what is happening here is Clojure cannot mutate things, right? So if I use a normal vector, okay, it will be just this, and there will be no way to change this, right? I can do conch new state and add my row 1 column 1 color red. Okay, this is just going to return a new vector which is not bound to new state. Okay, this is going to result in a valid code. This is going to return a new data. But if I look at this guy, it's going to be just empty vector because Clojure does not allow mutation. Okay, this is the core principle of Clojure of immutability, that you don't want to change your bound uh, sim identities like this. New state is always going to be same. Now, you need, for some applications, you need some, yes. Do you mean with the swap or do you mean with something like this? With this, with the atom, right? So that's right, right. Let's let's go back to the code and you can look at it. So you're saying that okay, this is not taking any mutex, and how does this work, right? Is that your question? Yes. It's meant to work across threads and it is thread safe. Um, Swap Bang is doing all the heavy lifting of making it safe. It does not work on the principle of taking a mutex because there are two types of concurrency. The usual ones that we see in Java is called pessimistic concurrency, where you are saying that there is going to be a contention, that there is going to be another thread who's going to overwrite whatever I'm doing. So let me take a lock and try it. With Clojure, the neat thing that you can do is there's a thing called optimistic concurrency, uh, which basically means that let's try and update this thing. And I have a way, because the way the data structures have implemented, to know if this was updated by some other thread, while the thread which was updating it also updated it, right? So there are just different ways of doing concurrency. There are more than two. There are even more. But Clojure implements optimistic concurrency. And this has to do very much with how the data structures themselves have been implemented. That is a different topic. It's a very fun one, but I think that will take more time for me to explain why it works with Clojure's data structures, why optimistic concurrency works better. But TLDR of that is uh, Clojure gives this out of the box, and it you don't have to worry about this data getting corrupted. I Yeah, yeah, yeah. And when you have to read anything from an atom, you have to deref it. So this is a reader macro version of it where you are derefing your state, right? If you just use it as it is, it's an atom. So as you can see, it's not the actual value it's holding, it is referencing the atom itself. So if you have to use a value, you're derefing it at that point in time. Yes, you can think about it like a pointer, that you deref something, and um, after this deref, somebody might have mutated it, but that's fine because you have derefed it at a point where it was not holding any value. It was an empty vector. By the way, atoms can hold. So you've seen that we started creating atom like this, right? And you have to pass it a data structure. Atom only works with Clojure data structures. You cannot pass it like a hash map from uh, Java. This won't work. So you have to pass sequence literals like set, vector, or a hash map. Right. So for that, you have to then figure out ways to kind of implement uh, Clojure's data structure to do that, or you do like one another way of doing this is you create another thread. That thread's job is just to make sure this uh, vector is not more than a certain size, right? That's the usual pattern that people use. This is something that I have also done in production where I basically needed a ring buffer, right? One approach to that is keep adding things to your vector and have a different thread just making sure the length doesn't go overboard. It has its limitations because it doesn't handle spikes well. There are implementations of this where people have actually implemented uh, extensions or like different variations of this where ring buffer is there, but it's implementing all the Clojure uh, interfaces, which is seekable, uh, associative. So basically, you can implement other data structures with Clojure as long as you are following the interfaces and you are following the convention that this is going to be a immutable data structure. So it can be done. Short answer, it can be done, but you'll need a bit of tinkering. It's not as out of box as these data structures are. All right, switching back to front end, I think we have our UI up. All right, we have the WebSocket connection is set up, the grid is rendering, and my event handlers are not set up. So let's fix that. Yeah, they're still in comment. What I'm trying to do here is connect to the JavaScript ClojureScript REPL. Sometimes it becomes wonky. So it first connects to something which is a shadow CLJS server, and I'm telling it that I need to connect to a REPL that you are hosting uh, on build app. This is basically a reference for this guy, the page that it is rendering, and we have switched to it. A quick way to test this is just send an alert, and there you go. And now I can switch back to this guy and evaluate my click handler. Okay, this should create clicks, and in my messages, I'm sending the click back. Now let's go back to our backend REPL and check state. There you go. So now we have state stored. All right. So you can basically now at this point say that, okay, like whenever somebody loads up a page, right, just send this back and render everything. Right. So on this refresh, if I want my server to kind of send me the latest state of this guy, I can. Let me add few more states. Okay, I need to compile this guy again. Let me bring this out. So we are storing the state. At the same time, we also have this whole chat handler, which is getting called whenever a WebSocket connection is set up. What I can potentially do here is say that, hey, like whenever I have a connection set up, just send whatever is there in the state to your UI. So I'm going to do this here. Right, compile this guy. There's a small nuance here that if you have used Composer, uh, if I want to reload my server, I can't do that because I have already created a server with these routes, and one of the handler is your chat handler, and I'm recompiling that. This is the same reason as uh, what I had to do with like the click handler. I had to reload the page. We'll have to reload our Clojure backend also. This is one of the very few parts that I don't like in this whole workflow is I have to restart my backend server also. While we are restarting our front-end server, front-end setup, might as well do this also. Meanwhile, if there are any questions, I think we can break for the day in next 5 minutes. I just need to run the server and we can end our stream for today. Uh, we'll use this time since the servers are just booting up to discuss or just if you have any other questions about Clojure or the setup I have, feel free to chime in. Yes, yes, yes. It's. I'm not sure. I can't say with confidence that they don't have. They might, depending on how they are structured. Basically, the problem is with how you are starting your Java server or basically your HTTP server, and the way to uh, the way around this is kind of holding a reference to your server, shutting the server down and starting it again. Then you don't have to restart your REPL, which I didn't do in this case. That's why I have to restart the whole server itself. Yeah. Mm-hmm. Right. Right. There are like very There are ways to like depends on like what your goal is. Do you need this validation at compile time? Then you have type closure, right? Do you need this validation for your interfaces? Then I would recommend something like Mully, which is a data schema library, which lets you do validations also, right? So there are ways to document the structure of your data, and that does become a problem because all you are doing in Clojure is defining hash maps, right? So you need some certain way to document your structures and also add validations to your structures because you want your interfaces to reject bad inputs, and you also want to kind of adhere to certain structures when you're responding. So I would say Molly will give you a lot of mileage in this case. Definitely something you should check out if you haven't. Sorry, Malli. I'll just send you the link on chat also. Yeah, yeah. I have uh, I have created a library on top of Mali for getting structured outputs from LLMs in Clojure. It's a very nice library which can do a lot of things related to structuring your data. Is there a chat in this meeting room? Yes. Or I can just, oh, there it is. There it is. Okay, let me just send the link. Okay, our backend REPL is up. Okay, let's start the server. I'm not sure about events. Yeah, yeah. These are the times. Yeah, these are the times I feel bad that I am not in US. Yeah, yeah. I'm part of the organizing community for Enclosure. I've missed attending Clojure Conch by like small margin two times. Like something else came up just when I could like come show up there. All right. No, no. I wanted to join in, and I had ticket one time, but I couldn't join in for other reasons. So just closing encounters with Clojure cons. No worries. Okay. Let's see if this works now. I have clicked on a few things. Technically, this should work, but I'm not sure. Yes, this is working. So, did you folks catch that? That I am sending bunch of things, and so far, whenever we refreshed our page, it was just a blank grid. But since what we are doing in the backend is let me switch to backend code. On connecting to WebSocket connection, I'm saying, hey, like whatever the state we have, just send it to UI, right? So I clicked on bunch of things. Backend says, okay, sending updates, and it's painting the. This is very suboptimal way, like somebody pointed out, but it's working, right? So we have a way to send updates to backend. We have send a way to kind of send canvas and send updates to UI. And this is where we'll pause now. And maybe next time around, I'll have like a publicly hosted server where all of us can kind of interact with it and hopefully make it even more public on Discord channel. So I'll pause for today. I'll switch to my video and stop the stream also.